early part of the 19th century. It evolved from a flat-bladed bit used in a carpenter's brace, and its invention was a definite turning point. These trusty tools come with different bits to fit a variety of screw heads. So all you have to do is apply the right torque, and it's mission accomplished. The job of making screwdrivers starts with coils of specially formulated steel. Wheels straighten a thick wire, and then it travels through an aperture. On the other side, a machine rocks back and forth as it cuts the wire to length and forces it through 4 dies. The first die narrows the steel to the required diameter. The others form a hexagonal bolster partway down. This bolster will allow a wrench to be applied to the screwdriver to increase its turning power. A quick shower washes away the lubricant, and these screwdriver shafts are ready for inspection. The technician examines them for defects and measures the length and the dimensions of the hexagonal bolster. Once he confirms that everything is to specification, the screwdriver shafts head into a machine that will transform the tips into a slotted shape. At the first 2 stations, the press flattens the tip. The third one trims it and stamps the part number onto it. The flat blade is probably the most common of screwdrivers. Its chiseled tip turns a standard slotted screw. After the screwdrivers are heat treated to increase their hardness, they sand the tips to shave off 1/10 of a millimeter. They confirm that with this slotted guide. Then they insert the screwdrivers into a different slotted device. This one shuttles them over to a grinding wheel. This wheel trims them to their final dimensions. Visually, the change is subtle, but this fine-tuning will make a big difference in the screwdriver's performance. Now they twirl in a machine that blasts the tips with mild abrasive. This texturizes the surface to allow this screwdriver to really grip a screw head. The texturized tip is the one on the right. Over at another station, a different kind of screwdriver is taking shape. This is a Phillips. Its tip has a beveled cross point to correspond with the Phillips screw. This machine carves ridges into the bevels of the cross point to give it extra gripping power. A press then slams into the other end of the screwdriver to create flanged grooves. These grooves will allow them to lock the screwdriver shaft into its handle. It's time for some positive vibrations. This vibrating feeder causes the screwdrivers to chafe against each other, and the action removes any waste material. After they texturize the cross-point tip, it's over to a laser machine. It etches the part numbers onto these polyurethane handles. And now for the gripping part. The assembler attaches the handle to the screwdriver blade. He then places the screwdriver in a machine that applies mechanical force to solidly entrench the shaft in the handle. With the screwdrivers now on a tray, they move through a curtain of plastic. A machine heat seals the plastic around the edges. The loosely wrapped tray then enters a special furnace, and the heat shrinks the plastic around the tray to neatly wrap up this job. It has taken several days to make these screwdrivers, and now they're ready for the twists and turns of any job. Tools like these screwdrivers are really an extension of the human hand. A quality tool will enable you to work with more precision. But of course, you have to grasp the fundamentals of your project. And depending on what kind of handyman you are, that could be a whole other story.